Yes, Assalamu alaikum. We will continue talking about binary search approval, and also we will talk about changing variable. Then, inshallah, we will record another video for the remaining part, for the remaining slides from part 2, inshallah, and I will share them with you today. Now we are going to approve this using substitution method. We have this formula T and O log N. Okay, this is our guess for this time complexity for this formula. As you know, or as we have studied, the time complexity for this formula is related to binary search, as written here, binary search, as we have studied before. And you know that the big O for the binary search is O, big O for log N for the binary search, because we just dividing the array. Okay, so we will depend on this one, and we should know this formula or this time complexity formula is related to binary search, and we should know that the binary search, the big O for binary search is log N. Now, in the substitution method, as we have discussed before, we have to guess something here. We will assume that Tn equal big O of the binary search, which is O log N. And now we will try to approve that. As we have mentioned before, we will assume some constant here, okay? And we will start our approval. So now we will approve regarding the big O. Because we are using the big O now, we assume that the time complexity here is less than the function, the big O of this function, the big O of this function, or the G of N for this function. Will rate of growth for this function, because we already know the big O, and we know that the big O, that means the worst case. Big O means the worst case when the output is greater than the input, or the expected output is much greater than the input based on N input. Okay, or the time needed is very high in this case. Big O. Okay, based on N. Now we just assume T of N less than or greater D, any constant, by log N. Now we have also in the binary search, now we are going to use this function here, T of N. Now we will, instead of using N, we will use N divided by 2, according to this time complexity, according to this equation here. Okay, so now I will replace. We have put here N على 2, and here we are going to replace this by N على 2 here and here. So here we have substituted N على 2. Now this is equal D of log N على 2. Okay, D of log N على 2. This one. So now we are going to say that T of N, equal T of N على 2 plus C. less than or greater than log n على 2 plus c. A plus c. As we have mentioned before, if we are dividing logs, we can subtract, convert the division of this one to subtraction. Okay, it will be subtraction here, this one. So we are now working on this part. Okay. So we will approve that now by writing d of log n. This is equal d of log n minus d of log 2. So we have substituted the division, the division operator by the subtraction here, and we have multiplied d by log n, and we have multiplied d by 2. So now we have d log n minus d log 2 plus c. This one equal d log n. Log 2, we mean by this the natural log, ولog 2 للبيس 2. This is log 2 للبيس 2 is equal 1. So 1 by d equal what? D. So we have d log n minus d. This is 1 now. A plus c. Now, d log n with d log n is removed. We have d plus c greater than or equal 0. Okay. Now this one will be moved here. Minus d log n. D log n. Log n. D log n minus d log n equals 0. So now we have minus d plus c greater than d. D plus c greater than 0. Now we have here, now we have this one. Minus d plus c greater or equal 0. Minus d plus c less than or equal 0. Now we have convert this thing like this, and now it is, this one is equal minus d plus c greater or equal 0. Now we have minus c greater or equal minus d. Now we have change the operator here from less than to greater than. So now, and because of that, we have converted these from negative to positive. So now we have multiply it by minus 1 because we have converted the comparison operator here from less than to greater than. So we have the greater than. Okay. This is for the binary search. Now, the last thing that we are going to talk about, and it is looks complex, but it is not complex. It is the changing variable. This one, we did not talk about this one in the class here. Which is was, I think, this slide, changing variable. Now, for this example, it looks like a little bit complex, but it is easy. Now we want to show you that changing some variable here will simplify the problem with you. So now we have T of n equal 2 by T n squared plus log n. So now, because we have something like squared and log n, so we have log n, we have some, yani, to simplify this formula, to solve this in order to be able to solve it. Okay. Now the first step here, we have rename m by equal log n. We have assumed that m equal log m here. So now 2 to the power m equal n. Okay, 2 to the power m equal n. Now if we have, so for this part, this is square root of n or n to the power half, which is equal 2 to the power m على 2. m على 2. Okay, because here we have n equal 2 to the power m. هذه we have substitute هذه n ب 2 to the power m. Now, and also we have divided, yani, because it is divided by 2, we have 2 here. Now, so now we have, really clear now, m log n, this means n 2 to the power m, square root of n equal n to the power half. This means we have substituted t to the power m, this one, by n divided by 2, which is half. Now, also we have replace n by 2 to the power m, because n we have assumed that m equal log n, so n equal 2 to the power n. So instead of n here now, we have replaced it by 2 to the power m. So we have 2 to the power m, 2t as this, 2 to the power m على 2 هيها n squared. هذا شو تساوي مثل ما اتفقنا 2 to the power m على 2 plus log n, which is m. Okay, now also we have simplified it more by replacing t of m by s of m. So now we have s of m equal t to the power rename. We have rename s of m, خلينا حولنا الm هي عبارة عن هذا. So we are replacing t of 2 to the power m by what? S m. Okay. So we have here 2 time and t of 2 to the power m, which is equal s of m. خلصنا هذا البارت. This part is because of this assumption here. Really clear? يعني هذا البارت بحسب هذا. So now we have 2 to the power t of t to the power m, which is s of m. Now we have t to the power 2 to the power m. We have replaced it by 2 s m على 2. Now we have s of m now we have this s of m equal 2 to the power t 2 to the power m. So now we have both s of m here, 2 to the power t of m, this one, s of m. Okay, now we have this part. 2 is as s here. Okay. Now we have S 2 T2 to the power M هي, which is S of M. S of M. But here we have M divided by 2. So we have put M divided by 2 here. Then 2 is we have written 2 as is here. Now we have 2 to the power 2 of M, which is equal S of M. S of M. Okay. But because this M is divided by 2 also, we have divided by 2 here. A plus M. M as is here. Okay. Now I will clear. So we have now SLM equal O of S of M. Now this one is representing what, guys? If you remember, this one representing the merge sort. Merge sort, right? Because we have 2 S of M على 2 plus M. Okay. This is the complexity of merge sort. So this is have been demonstrated before, which is equal OM log N. Or O, if you remember, N log N, we have mentioned that a lot in the class, which this represents M log N, which is represent what? The merge sort. And this is the formula for it, okay, for the complexity for this algorithm. So now S of M equal O of M log N. O of M log N. Demonstrated before, refer back to what? Refer back to merge sort. Now we have 2 of N. I have O of M log N as is. S of M as is. Now we have T of N equal T of 2 of M. This is we have what we have done before, which is equal S of M, which is equal O M log N. Now M, we have M here. M equal log N. M equal log N. And we have log, another log here. And M. M also equal what? Log N. M log N. So now what we are trying to guess, now we have simplified the formula here. Simplify it. So we are going to get that S of M equal O of log N. S of M is equal O of log N. So now we have, as always, أخذنا ال S of N ضربناها. We have multiplied it by a constant. Then we have replaced it by N على 2, which is C log N divided by 2 multiplied by log N على 2. And then we have done the same operation here. See, for multiplication, we have subtract these logs together and also subtract these logs together and multiply it by log N by 2. After that, we came with this one. Now we have C log N على 2 في log N على 2 plus N. Okay. This one here. C في log. Now we have proof of induction called Cn2S of N 2 على 2 plus N less than or equal C log N على 2 log log n على 2 multiply by log n على 2 plus n. Now the idea هون here we have two things to think about. First of all, renaming the variable here, renaming to simplify the formula or equation, and also the other thing that we have used, that this one demonstrated before. Now, if we have something we have approved before, we can just write it and simplify it and write here demonstrated before. As we know, this is the this equation or this time complexity is for the merge sort. So merge sort is equal m log n, which is this one. So anything that you have seen before, you can use it, convert it as it was or as you have approved it before. So we have here log n على 2 multiply by log n على 2 here. And this is of course correct because here we have something to the power, Of course, the log n على 2, this one equal c في log n minus c في log 2 في log n minus log 2. Okay. So sometimes you need to change this variable and come to this approval. So you can change the variables, simplify the formula, and if you have reached to a pattern that might help you to simplify more, use it and write demonstrate before, then again replace it by the original value here. Okay. So this is about changing the variable. So now we have finished part 1 from chapter 4. We have finished the part 1 from chapter 4, part 1. So now we are in chapter 4. Chapter 4, guys, just to be, to make sure that we are on the same page, it consists of two. We have divided in 2 parts. Part 1, which is was on last Sunday. Now we have finished from part 1. Now I will record another video for part 2 for chapter 1, part 1. So now we will record, inshallah, a video for these slides here, starting from the recursion tree method and also the master method. So we have explained two methods. The first method was about linear iteration. Then, as we have mentioned, we have substitutions. Okay, I will not write it. Now we have another 2 methods. We have the recursion tree. The recursion tree method. We mean by this we are going to simplify the recursion to 3 and we'll find the sum of the cost for each level. Then find the summation for all levels together. Okay. And the other method is the master theorem. The master theorem. We have in this theory three possibilities. We will discuss it, inshallah, later. If the function is less than the growth of function, or of the output of the function equal, we will use theta or big O. if the function is less, output is more than the output of the function. If the function is here, input is greater than the growth of function, so we will just use some formula for this. So in the master theorem here, we have three possibilities. We will discuss this possibility later. And also we have another method, which is a master theorem method, and we have recursion tree method. We have this 1 and 2. Okay, so as we have mentioned here, we have a tree. We will find the cost from each level, breadth by level. Then we will find the sum of all the cost. And in the master theorem here, we have three possibilities, M big O, and we have something to do here. Maybe it's theta. We have another thing to do, three possibilities, and we might have big omega. And in that case, we are going to also use other method. So next recording will be about this part, inshallah. Thank you for listening. Please see these records and listen to them carefully. I hope this recording will help you while studying, inshallah. Thank you.